Welcome pre-cal students to the homework help video, page 919, 5 through 25 odd. This is the review sheet for your test. So let's go ahead and get started and see how you've done. Let's take a look at number 5. Find the first 4 terms for this nth term, and then find terms 11 and 23. Now, first of all, understand this is not necessarily an arithmetic or a geometric sequence, and we really don't care. We're just trying to find the first four terms. So I'm going to put a 4 right here. I'm going to put a 4 right here. And excuse me, that is incorrect, and I apologize. We're finding the first 4 terms. We're going to put a 1 here, and a 1 here, and a 1 here. Negative 1 to the 1 power is negative 1. Negative 1 to the 2nd power is 1. 1 to the 4th power is 1, plus 1 is 2. So we have negative 1 times 1/2, so my first term is negative 1/2. Let's take a look now at the second term. Everywhere there's an n, I'm going to put a 2. So we will put a 2 right here, a 2 here, and a 2 here. Negative 1 squared is positive 1. Negative 1 times negative 1. 2 squared is 4. 2 to the 4th power is 16, plus 1 is 17. So I would have 4/17 times 1, and of course that would just be 4/17. All right, let's go ahead and put a 3 in and find our third term. We'll put a 3 for this n, a 3 for this n, and a 3 for this n. Negative 1 to the 3rd power. Negative 1 times negative 1 times negative 1 is negative 1. And then 3 to the 2nd power would be 9. And 3 to the 4th power would be 81. So 81 plus 1 would be 82. 9 over 82 times a negative 1, that will give you a negative 9/82. And then let's take a look and see if we can't quickly find the fourth term. And you would put a 4 here, and a 4 here, and a 4 here. Alright, so negative 1 to the 4th power would be a positive 1. 4 squared would be 16. 4 to the 4th power would be 256, plus 1, of course, because I have a plus 1 right here. And that would give me 16 over 257 times 1, which is 16 over 257. So there we found the first 4 terms. Now let's quickly find the 11th term. Everywhere there's an n, I'm going to change colors here. Everywhere there's an n, I'm going to put an 11. So there's an 11 there, an 11 there, and an 11 there. Well, negative 1 to the 11th power is negative 1. 11 squared would be 121. 11 to the 4th power, of course you can use your calculator for that, is 14,641, and of course plus 1. So I would have 121 over 14,642 times negative 1. So the 11th term would be, we'll put it right here, a subscript 11 would be negative 121 over 14,642. Now let's find the 23rd term. So everywhere there's an n, I'm going to substitute 23. Negative 1 to the 23rd power would be negative 1. 23 squared is 529. And 23 to the 4th power would be 279,841. And then plus 1. So it looks like my fraction would be 529 over 279,842. Then times the negative 1 just makes it a negative fraction. So negative 529 over 279,842, and that would be your 23rd term. Kind of a long problem, but they're just getting you to practice substituting numbers into an nth term and getting out a certain term. All right, number 6. Predict the general or nth term, and your answers may vary. Now, I worked on this one for a while, and I had to kind of think it through. It's not an arithmetic. Let me go ahead and tell you now, it's not an arithmetic sequence because you're not adding the same number over and over. And it's not a geometric sequence because you're not multiplying the same number over and over. So we're going to have to be creative. So that's the first term, second term, third term, fourth term, fifth term. And what I noticed was this. I noticed each of these terms. And by the way, forget the negative and positive signs for a second. Remember, I taught you we can take care of that by using -1 to the n power or -1 to the n minus 1 power. So that's something we can worry about later. Now, what I noticed is each one of these numbers is one more than a perfect square. For example, 1 is a perfect square plus 1. 4 is a perfect square plus 1. 9 is a perfect square plus 1. 4 is a perfect square plus 1. 5 is a perfect square plus 1. And so, actually, I said that wrong and I apologize. I would say right here, 16 is a perfect square plus 1, and 25 is a perfect square plus 1. And a perfect square means, very simply, we know the square root of that number. See this 1 right here? I can rewrite that as 1 squared plus 1, and that would still give me 2. See this 4? I can put 2 squared plus 1, and I would still get 5. Don't worry about the negative sign. I could put 3 squared for 9 plus 1. For 16, I could put 4 squared plus 1. For 25, I could put 5 squared plus 1. And now, if you'll kind of look here at what's happening, it's a really neat pattern. I mean, a really neat pattern. And here it is. It's pretty easy to see once we've written it like this. Look. Notice how all of these numbers have a plus 1, plus 1, plus 1, plus 1. So we know that our nth term is going to have a plus 1 at the end. Also, notice how all of these terms have an exponent of 2. So I know for sure I'm going to have an exponent of 2. Now, notice the first term has a 1, the second term has a 2, the third term has a 3, the fourth term has a 4, and the fifth term has a 5 right here. So all of these bases match the term number. So I can just put an n squared plus 1. So there, I've almost written my nth term. The only thing left for me to worry about is the negative sign. And remember, we've talked about this before. Whenever you have alternating signs, positive, negative, or negative, positive, positive, you have to put something out front. It's either going to be -1 to the n or -1 to the n minus 1. Well, let's try -1 to the n. If I put a 1 in for n, now watch this please, watch carefully. If I put a 1 in for n, -1 to the 1 power is a -1. And that means I would get out a -2, and I don't want that. So instead of putting an n right here, I'm going to go ahead and put n minus 1. Actually, you could put plus 1 too if you want to, either way, n minus 1. Now that'll work. See, this first term is 1. Put a 1 in right here. 1 minus 1 is 0, and -1 to the 0 power is 1, and then 1 times all of this would give you 2 if you put a 1 right here. If you put a 2 in for n right here, a 2 for the second term, 2 minus 1 is 1, and -1 to the 1 power is -1. And then 2 times 2 is 4, plus 1 is 5, so 5 times -1 gives you a -5. So we are going to want an n minus 1 right here. And there you go. That's it. We found the nth term. All right, number 7. Find and evaluate. So we're going to put a 1 in, a 2 in, a 3 in, and a 4 in, and add all of this together. So I would have -1. Okay, we're going to put 1 in first. So imagine there's a 1 right here. 1 plus 1 is 2. So I'm just going to go ahead and put a 2. times 3 to the 1 power all over 3 to the 1 minus 1. Let's go ahead and work this out. Negative 1 squared would be a positive 1 times 3 all over 3 to the 1 is 3 minus 1 is 2, so 3 over 2. So your first term is going to be 3 over 2 plus, and now let's come up here, and now let's put 2 in everywhere there is a k. So if we're going to put a 2 in, we would have negative 1, and then put a 2 here. 2 plus 1 is 3, and then a 3 to the second power all over 3 to the second power minus 1. So negative 1 to the third power is negative 1 times 3 squared is 9, and then 3 squared is 9 minus 1 is 8. So we end up with negative 9 over 8, or in other words, negative 9/8. All right, let's find the third term by putting a 3 in for k. All right, let's put a 3 in for k right here. 3 plus 1 is 4, so we have negative 1 to the fourth power, and then 3 to the third power, and then 3 to the third power minus 1. Negative 1 to the fourth power would be a positive 1 times 3 to the third power would be 27, and then down here we'd have 27 minus 1, which is 26, and so we end up with 27 over 26. And then lastly, let's put 4 in. We'll have the fourth term, and we'll add all of these together. So where the k's are, we're going to put a 4. So I would have negative 1 to the fifth power times 3 to the fourth power over 3 to the fourth power minus 1. Now negative 1 to the fifth power is negative 1 times 3 to the fourth power should be 81 all over 3 to the fourth power, so 81 minus 1 would be 80. And then 81 times negative 1 is a negative, so we would have plus a negative 81 over 80. Now, you're pre-cal students. I'm not going to type all of this in right here into your calculator and add that up for you. I have an answer key here, and I'm looking, and it looks like the answer is 417 over 1040. So if you add all of those fractions together, you will get 417 over 1040. Okay, so we found the sum of 4 terms by finding each term and then adding them together. Okay, number 8, we're going to write sigma notation. Now let's start off with the easy part first. The easy part is to count how many terms that I have. 1, 2, 3, 4, 5, 6, 7. And so I know, let's just say n. We know n is going to start with term 1 and it's going to end with term 7. All right? I'm going to move this down and get a little space here. So that's the easy part. Now we got to find the nth term that goes with this sigma notation. So this is a 1, this is my second term, third term, fourth term, fifth term, sixth, and seventh term. Now one thing I noticed here is each one of these numbers is 1 less than a perfect square. For example, 1's a perfect square minus 1. 4 is a perfect square minus 1. 9's a perfect square minus 1. 16 is a perfect square minus 1. 25 is a perfect square minus 1. 36 is a perfect square minus 1. And 49 is a perfect square minus 1. Okay? Now it takes a lot of practice to see these little things, but you'll get used to it. Now for this 1 right here, I could write 1 squared minus 1. For the 4, I could put 2 squared minus 1. For the 9, 3 squared minus 1. For the 16, 4 squared minus 1. For the 25, 5 squared minus 1. For the 36, I could put 6 squared minus 1. And for the 49, I could put 7 squared minus 1. Now look what I have here. Notice all of these terms have a negative 1, so I know I'm going to have a minus 1. And notice all of them have a power of 2, so I know I'm going to have a power of 2. And then notice how this base here matches the term number, 2 here, 2 here, 3 here, 3 here, 4 here, 4 here, etc. So I know I'm just going to have an n. So my nth term then would be n squared minus 1. Now be careful with this. I would encourage you to put parentheses. You really should. There's no encouragement to you. You really should put parentheses around this, because if you don't, what it really does look like is you're taking the summation notation of n squared, then after you've done all that work you're subtracting 1, but really you're taking the summation notation of this entire expression, so you do want to put parentheses around it, and there, we did it. So not too bad. Let's continue on now to number 9. Number 9 says find the 10th term of the arithmetic sequence. Well, that's nice of them to tell us we have an arithmetic sequence, and so that means we can take any number we want in the sequence and subtract from it the term previous before it. So very quickly, if I do that, 3/4 is really the same thing as 9/12, I believe, and so 13 minus 9/12 is 3/12, 1/4. So what we're doing here is we're adding 1/4 over and over and over. All right. And no, that cannot be right. So hold on 1 second, please. 13 over 12 minus, we're adding 1/3. Sorry about that, students. We're adding 1/3 over and over and over. Okay? So, we do know now that our common difference is 1/3. That's what we're adding over and over and over. And we know our first term, of course, is 3/4. Now, if we want to find the 10th term, I would recommend we first find the nth term. And of course, the formula for that is a subscript n equals a subscript 1 plus n minus 1 times d. So very quickly, my first term is 3/4 plus, and then n minus 1 times d, and d is 1/3. So there we have our nth term. And how is that helpful? Well, now that I have my nth term, if I want to find the 10th term, all that I do is I put 10 in for n right here, and I can find my 10th term. So this n right here is about ready to become a 10. And then 10 minus 1 is 9. So I have 9 times 1/3. Over here, bring down your 3/4 and your plus sign. And then remember, you don't add first, you would multiply first. So 3/4 plus 3, because 9 times 1/3 is 3, and 3/4 plus 3 is 3 and 3/4. That is a fine answer. Or 15 over 4 is also a good answer. All right, let's move on now to number 10. All right, find the 6th term of the arithmetic sequence. Now this problem looks a little different, students, because if you'll look, your terms have variables, but all the steps are still the same. We're going to find the 6th term, so don't forget, eventually we're going to need our formula a subscript n equals a subscript 1 plus n minus 1 times d. Now, the first thing we need to do, we know what our first term is. We know that our a subscript 1 is a minus b. We know that. But we have to find the common difference. Now remember how we do that. We can take any term like this, a plus b, and subtract out the term before it. So I have a plus b minus a. Well, if I have a plus b minus a, notice I have a positive a here and a negative a here. They cancel out, leave me with b. So it looks like my common difference is b. Let's see if that's right. Negative a, sorry for yawning, negative a plus b would give you a, so that works. And a plus b would give you a plus b. So it's obvious our common difference would be b. So I come over here, and here's my nth term. My nth term is a subscript 1. I'm going to put parentheses and put a minus b. I put parentheses because it's 2 terms. That's my first term. Plus n minus 1 times d, and my common difference is the letter b. Now, I want us to find the sixth term, so that means for n right here, we're going to substitute a 6. So there's my 6. Now be careful with your algebra simplification, okay? First of all, a minus b in parentheses is just a minus b, all right? And then plus, multiply this b through, so 6 times b would be 6b, and then negative 1 times b would be negative b. And now if you combine your like terms, you have a negative b and a negative b, that's a negative 2b, plus 6b, that's a 4b, so you have a plus 4b, and that would be the sixth term. Okay? If you need to back that up and watch it again, do so. But that is how you would solve number 10. All right, number 11. Find the sum of the first 18 terms of the arithmetic sequence. Well, they're kind enough to tell us we have an arithmetic sequence. So I'm going to go ahead and write down my formula. The sum of an arithmetic sequence is n over 2 times the sum, first term, plus the last term, a subscript n. Now we're finding the sum of 18 terms, so the sum of 18 terms equals, here's an n, so I substitute 18 over 2, all over, a subscript 1 is 4, plus, there's an n right here, so that's really an 18. Ooh, I've got a problem, don't I? The problem is I don't know the 18th term. Alright, now I guess I could add 3 quickly over and over and over to find the 18th term, and I could do that relatively quickly, and that's not a bad idea. Another way to do it, to find the 18th term, because remember we can't find the sum unless I know the first term and the last term of the arithmetic series that I'm adding. So another quick way to do this to find the 18th term is very quickly write the nth term. The nth term would be a subscript 1 plus n minus 1d. So a subscript 1 is 4 plus n minus 1. Now of course the common difference, as you can see, is 3. We're adding 3 over and over. So now put 18 in for n real quick. So 4 plus 18 minus 1 times 3. 18 minus 1 is 17. So now we have 17 times 3, which would be 51. And then 4 plus 51 would be 55. So there, we very quickly found the 18th term. And so the 18th term goes right here. And now we're ready to go ahead and find the sum. So next we would have 9, because 18 over 2 is 9, times 4 plus 55 is 59. And so of course 9 times 59 is going to be 531. And so the sum of those first 18 terms is 531. All right, let's take a look at number 12. Find the sum of the first 200 natural numbers. Okay, well that means I would have 1 plus 2 plus 3 plus, and then dot 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 plus all the way to 200. So I'm finding the sum of the first 200 natural numbers. Now notice I do have an arithmetic sequence because I'm adding the same number over and over and over. I'm adding 1, adding 1, I had a 1, then I had a 2, so I had a 1, I have a 3, so I added 1. Every term is increasing by 1. So I know that I have an arithmetic sequence, so I'm going to say the sum of 200 terms equals 200. I guess I should write the formula over here. The formula is S subscript n equals n over 2, and then first term plus the last term. Alright, so 200 over 2, because I have 200 terms, times my first term is 1, and my last term would be 200. Alright, so now I have 100 times 201. And of course that would give us 20,100. 20,100. So there, we found very quickly the sum of the first 200 natural numbers. We realized we had an arithmetic series, so we used the formula that helps you find the sum of an arithmetic series. Number 13, the first term in an arithmetic sequence is 5, and the 17th term is 53. Find the third term. Now, this is going to be pretty hard to do unless we can first of all find the common difference, okay? So think about this. My first term, a subscript 1, is 5. And then way over here, my 17th term is 53. Okay? Now the difference between 5 and 53 is 48, correct? If I took 5 and I added 48, I would get 53. So the difference between these two numbers is 48. Now, that's a really big gap. I'm going from the first term to the 17th term. But what if I said to myself, hold it, from the first term to the 17th term, 17 minus 1 is 16. What if I take this really big difference and I divide it by 16? Because remember, from term 1 to term 17, there's 16 gaps through here. If I divide by 16, I'll get 3. And that tells me what the common difference is. If I had 3 over and over and over, by the time I get to the term 17, it'll be 53. So I know 5 is my first term, and then 8, and then 11, and then 14, and then 17, and then 20. And trust me, students, if you continued on, when you got to the 17th term, you would hit 53. So once again, what I did is I found the total difference all the way across from term 1 to term 17 is 48, and then I realized, hold it, I've got a gap from 1 to 17, I've got a gap of 16, so I'm going to take that total difference, 48, divided by 16, and now I see that each little gap is 3. So my common difference here would be 3. So now I know a little more information that will help me solve this problem. They want us to find the third term, so I can do that quickly. The second term would be 8, and the third term would be 11. Because we know the common difference is 3, so I just added 3 a couple of times to find the third term. Okay? Pretty simple. Let's go on now to number 14. The common difference in arithmetic sequence is 3. The 10th term is 23. Find the first term. Now, if you're at term 23 way over here, and you want to get all the way to term 1 over here, yes, you can take your calculator and subtract 3 because you're going backwards. Subtract 3 over and over and over until you get to the first term. But that's going to lend itself to probably making a mistake. I would like to suggest that we use this formula here, the nth term formula, and let me show you how we can do that. Okay, first of all, we're going to deal with the 10th term here, okay? We know the 10th term is 23, so I'm going to say 23 equals, let me just stop right there and do this a little better. See these ends right here? I'm going to make these ends become 10 because we are looking at the 10th term. Alright, and why are we looking at the 10th term? One simple reason. We know what the 10th term is. It's 23. If they would have given me the 12th term, then I would have put a 12 in. If they would have given me the 13th term, I would have put a 13 in. But they gave me the 10th term, so I'm going to put a 10 in for n. Now, the 10th term, a subscript 10 is 23 equals a subscript 1. That's what I'm looking for, so I'm going to leave that alone. Plus 10 minus 1, that would be 9, and then the common difference is 3. So this is pretty easy. I have 23 equals a subscript 1 plus 27. Now bring the 27 over and make it a negative 27, and that would leave us with negative 4 for your first term. Alright, so negative 4 would be your first term. So sometimes this nth term formula can be used for more than one thing, just depending upon what you've been given and what you're looking for. Alright, number 15. Now we're dealing with geometric sequences. For a geometric sequence, the first term is 2, the common ratio is 2, and a subscript n is negative 64. Find n, in other words, find what term negative 64 is. Then after you've done that, find the sum of all of those terms. Okay, let me read it again. We have a geometric sequence. The first term is negative 2. The common ratio is 2. And we know that one term is negative 64. Find n, or in other words, find what term a subscript n, find n. So find what term negative 64 is. Is it the first term, second term, third term, fourth term, etc.? Now, to find what term negative 64 is, you could definitely say the first term is negative 2, and the common ratio is 2, and you could quickly multiply by 2 because the common ratio is 2 over and over. So negative 2 times 2 is 4, negative 4, times 2 is negative 8, times 2 is negative 16, times 2 is negative 32, times 2 is negative 64. And there, you found us a sixth term. So negative 64 is the sixth term. So we answer the first question right here, n is 6. But by the way, if you're like, well, Mr. Earhart, how about a formula? Sure, there's a formula. Remember, the nth term of a geometric series is a subscript n equals a subscript 1 r n minus 1. Now we can do this using a formula. This was a lot faster up here, but you could do this. You would say for your nth term, you're going to call it negative 64 equals, your first term would be negative 2, and then of course your common difference is 2, n minus 1. This is a lot of algebra 2 here. Now we're going to divide both sides by negative 2 to get rid of this negative 2 right here. So if we divide one side by negative 2, we divide the other side by negative 2, that would leave us with 32 equals 2 to the n minus 1. And then we rewrite the 32 right here as 2 to the fifth power, because 2 to the fifth power equals 32. And now just use your imagination for a second. These two sides are supposed to be equal. They both have a base of 2 right here. So you could put a 6 right here for n, and 6 minus 1 is 5, and both sides would be equal. So it shows me right there that n has to be 6, which is what we knew up here already. So this way was a lot faster, but you can use that formula if you want to. So we answer the first part of the question. We know negative 64 is the sixth term. Now they want us to find the geometric sum for these 6 terms. Now here's the formula that we have. Remember, there's 2 formulas for finding the sum of geometric series. One formula is when you know how many terms you have. The other formula is when you don't know how many terms you have. And in this case, we do know how many terms that we have. And so we're going to use this formula here. A subscript 1 in the top of my fraction times 1 minus r to the n, and that would be all over 1 minus r. Now, we know we're finding the sum of 6 terms, so the sum of 6 terms equals a subscript 1 is negative 2, 1 minus, the common difference would be 2, to the n power, which would be a 6, all over 1 minus r, 1 minus 2. All right. Now, we can do a lot of this in our head. We would have negative 2 in the numerator, and then we know 2 to the 6th power is 64, so 1 minus 64 would be 63, and then 1 minus 2 is negative 1. 2 times 63 would be a negative 128. All over a negative 1, and so the sum, if you add all of those together, is going to be 126. I apologize. And this would be a negative 63 here, which would give you a positive 126 here. So positive 126 divided by a negative 1 would be a negative 126. So we use this formula here for 2 reasons. A, we had what type of sequence, geometric, and B, we knew how many terms we were finding the sum of. Let's take a look at number 16. All right, we have a geometric sequence. We know the common ratio is 1/2. We know n equals 5. And we know the total sum is 31 over 2. And so they want us to find a subscript 1. And they want us to find also how many terms that we have, okay? So here we go. First of all, we're dealing with finding a sum of a geometric sequence with a set amount of terms. So my formula is going to be S subscript n equals a subscript 1 minus r to the n over 1 minus r. Now watch what I do here, please watch this. The sum of n is 31 over 2, so I can put 31 over 2 right here equals, I do not know what a subscript 1 is, so I'm going to leave that blank. Alright. Then next I have 1 minus r, which would be 1/2 to the 5th power all over 1 minus r, 1 minus 1/2. Now, I'm going to simplify this right side of the equation, and I have 31 over 2 equals, now watch carefully what I do here, 1 minus 1/2 to the 5th power. Well, using a calculator, it will do all of this for you. 1 minus 1/2 to the 5th power will give you 31 over 32 if you did that correctly using a calculator. And then your denominator would be 1 minus 1/2, which would be 1/2. Now I've still got to simplify this sorry students, I've got to simplify this right side right here a little more still, so we're going to continue that over here. Now if you'll watch, I think this will make sense. I mean, a subscript 1 times this right here is really just the same thing as that right there. And I'm going to go ahead and just get rid of these parentheses. So you really just have 31 over 32 a subscript 1 is what you have. Now, if you take 31 over 32 divided by 1/2, or in other words times, and then flip it 2 over 1, you get 31 over 16. So what you end up with, if you simplify correctly, is you're going to end up with, hold on one second. Okay students, I'm back. Sorry about that. My computer completely froze up and I lost everything we were doing there. So I apologize for that. That happens sometimes, but at least I didn't lose the video. So, okay, I think we had 31 over 2 equals, and I think we had just said, let's see, I think we had said what? 31 over 32 times 2 over 1 was 31 over 16. So we would have 31 over 16 a subscript 1. Now, I hope that's right because I lost all that information we had. But anyways, if we now divide both sides by 31 over 16, and your calculator will do that for you students, okay? I mean, that's what the fraction button is there for. If you put 31 over 2 in parentheses, divided by, and then put 31 over 6 over 16 in parentheses, your calculator will do all that for you, and you get 8. Okay, so we get 8 equals a subscript 1. So now we know this right here is 8. Alright, and now lastly, they want us to find the 5th term. Well, I can do that pretty quickly, students. Usually I want us to use formulas, but if the first term is 8 and I want to get to the 5th term, That's really easy. What's our common ratio? 1/2. So 8 times 1/2 is 4. 4 times 1/2 is 2. 2 times 1/2 is 1. And 1 times 1/2 is 1/2. So there we go. We found our first term and we found the fifth term. All right, moving on to number 17. Number 17 says, find the sum of each infinite geometric series if it exists. Now notice these are geometric series, and notice that they're not telling us how many terms that we're going to add. So what that means is we're going to use the infinite geometric sum formula, which is, in X I should put a infinite symbol here, equals a subscript 1 over 1 minus r. And of course your common ratio has to be between -1 and 0. And we find the common ratio by taking this number right here and dividing it by this number. Or you could take this number here and dividing it by this number, or you could take this number here and divide it by this number. Either way, you can go ahead and do it if you want. You will get out, I'm not sure why I put a 0 right here, students. What I said is your common ratio has to fall between -1 and 1. There we go. You're going to see if you take any of these numbers and divide by the previous term, you are going to get a number that's greater than 1. It's 1 point something. So there's no solution. You cannot find the sum of an infinite geometric series unless your common ratio is between 1 and -1. And your common ratio for this problem is greater than 1. So it does not work. So the answer is no solution or cannot be done. All right, let's take a look at number 18. Let me get a drink real quick. Okay, it looks like to me that if we take 0.0027 and divide it by 0.27, we're going to get 0.01. So the common ratio, I took this and I divided it by the term to the left. The common ratio is 0.01, and that's good. That does fall between -1 and 1, so I can definitely find the sum of this infinite geometric series by simply saying a subscript 1 over 1 minus r. So my first term is 0.27 and my denominator is 1 minus 0.01. Alright, well, if you type this whole thing into your calculator, 0.27, well, first of all, 1 minus 0.01, you're going to get 0.99, and then if you take 0.27 divided by 0.99 and hit that into your calculator correctly, type it correctly, you will get out 3/11 for your answer. So we call 3/11 your sum, or you can also call it the limit of this geometric series. Okay. All right, number 19. Let's see if we can find a sum of this infinite series. I'm going to take -1/6 right here, and I'm going to divide it by its previous term. So -1/6 divided by 1/2, that means times 2 over 1. Your 2 would cancel into your 6. Negative times a positive is negative. 1 times 1 is 1. 3 times 1 is 3. So it looks like we're multiplying -1/3 over and over and over. And does -1/3 fall between -1 and 1? Sure. Here's 0. It would fall about right here. So our common ratio is good. Our common ratio is -1/3. And our first term is 1/2. So we're ready to find the sum of this infinite geometric series. So 1/2 is a subscript 1 over 1 minus a -1/3, which is your common ratio. Well, first of all, I would have 1/2 over 1 1/3, or 4/3, because 1 minus a -1/3 is 1 plus 1/3, which is 1 1/3, which is 4/3. And then 1 divided by 4/3 would be, let's see, or excuse me, the top is 1/2. I apologize. My fault. And there we go. 1/2 divided by 4/3 is 1/2 times 3/4. If you use a calculator or work it out longhand, you will get 3/8. So we simply say 3/8 is the sum of the infinite geometric series, or we say it is the limit. All right. And number 20, find fraction notation for 2.43. Now I know we've never done this, but let me show you something. We have 2.43. And then we could say plus, or let's see, I'm trying to think of the best way to explain this. Okay, the best way to explain this is, and I know we've never done one like this. This is a really good thinking problem. What I'm going to say is I have 2.43 repeating, and they want to know what fraction equivalent would give us this. Well, forget the 2. We're going to add that down to our final answer. So we know we're going to have 2 and then a fraction. Now 0.43 could really be rewritten as 0.43 plus 0.0043 plus 0.00043. How, Mr. Earhart? Because look, guys, the bar over the 43 means it's repeating. Is it not? And so if you take 0.43 plus this, you'll just get 0.434343, which is totally legit. In fact, the next thing you could add would be 0.123456643. Take your calculator, add all these together, and here's what you'll get. You'll get 0.43434343. And that's the same thing as this, because with 0.43 with the bar over it means the 43 is repeating. So I know this is new, but still it's good. It's good for you to think about this. So no idea what happened. Okay, we're back. So here's what we're going to say. Since all of these numbers add up to 0.43 with a bar over it, then if you look, I have an infinite geometric series. Look, if you take this term here and divide it by this term here, you're going to get a common ratio of 0.01. And check and see if you don't believe me. You're multiplying 0.01 over and over. And so we have a geometric sequence, and it's infinite. And look at our common ratio. It's in between 1 and -1, correct? Sure it is. So I can very quickly find the sum of all these numbers and watch what happens. A subscript 1, 0.43 over 1 minus r, so 1 minus 0.01, which would give me 0.43. Now watch this. 0.43 over 0.99. All right. Now, if I move the decimal place 2 up top and 2 in the bottom, I end up getting 43 over 99. All right. So remember, I already had the whole number. I had 2.43. So if you don't believe me, type in 43 divided by 99 into your calculator. Go ahead and type in right now. Type in 43 divided by 99, and you'll get 0.4343434343. It works. And don't forget there is a whole number with it. So really the answer is 2 and 43/49. That's a tough problem. I could see me definitely giving you one of these in a test, though. Okay, it would really be good for you to think a little bit about this. All right, number 21. All right, insert 4 arithmetic means between 5 and 9. All it means is this, is you have an arithmetic sequence, and 5 is your first term, 9 is over here, and they want you to insert 4 numbers. 1, 2, 3, 4. Now be careful, please. Please be careful. The total difference from 5 to 9 is 4. But look how many gaps I have. I have a gap here, a gap here, a gap here, here, and here. 5 gaps. In other words, this total difference from 5 to 9, 4, I've got to divide that by 5 spaces because I'm going to add that number over and over and over. It's an arithmetic sequence. So this total gap of 4 has got to be divided by 5 because I have 5 spaces. So my common difference is going to be 4/5. And watch what happens. You'll see 5 plus 4/5 is 5 4/5. Plus 4/5 more would be 1. What would that be? That would be 6 3/5, I believe. I hope that's right. And then add 4/5 again, and I think we'd get 7 2/5. And then add 4/5 again, and we would get 8 1/5. And then add 4/5 again, and we get 9. Perfect. So these are the 4 numbers right here that you would insert. This is your answer right here. Those are the 4 numbers you would insert. Okay, pretty interesting. Pretty interesting. Okay, let's take a look now at some word problems, 22, 23, 24, and 25. We're actually going to skip 23. It's an amazingly difficult problem, and if you want me to show you how to do that, in fact, I would like to. On Monday, when we're all together, I'll walk you through it very, very slowly, and I will explain to you how it works, okay? But number 22, a golf ball is dropped from a height of 30 feet to the pavement. Every time it rebounds 3/4 of the distance that it fell. How far up and down will the ball have traveled when it hits the pavement for the 6th time? Okay, let's just get a picture of this. We drop the ball and it goes down. Let's make it pretty long here. And it goes down 30 feet. Now when it rebounds only 3/4 of that, I believe is what it said. Let's see if that's correct. Yes, 3/4. And so if we take 30 times 3/4, we will get 22.5. So the ball goes back up 22.5, but then of course it has to come back down the same distance, so it comes back down 22.5. Now when it rebounds this time, it rebounds 3/4. I'm typing it now into my calculator. It rebounds 3/4 of 22.5. So 22.5 times 0.75 would give me 16.875. So this time it goes up 16.875, but it also has to come down 16.875. Now, I'm going to do this one more time, okay? And then I'm going to look for a pattern. So 16.875 times 0.75 would give me 12.65625. So it rebounds 3/4 of the way again, which gives me 12.65625, but then it has to go back down that amount also, 12.65625. It's a pretty tough problem. Let's watch, okay? See if we can't figure this out. Now, this is when it hit the pavement the first time. This is when it hit the pavement the second time. This is when it hit it the third time. And this is when it hit it the 4th time. Okay? Now, please watch carefully what we're doing. Again, this is a very difficult problem. I know that, but let's see if we can't figure this out. So the ball traveled down 30 plus, and then it went up and down 22.5. So 22.5 times 2 would give us 45, and then it went up and down 16.875. Multiply that by 2, and we'll get 33.75, and then it went up and down 12.65625. So times 2, and that would be this right here, 25.3125. Now, watch carefully what I've done. I have found I have found the total distance, if I add all those up, that the ball has traveled when it's hit the pavement 4 times. They want us to do this when the ball hits the pavement 6 times, okay? Now please watch this carefully. I want to show you something here you need to see. There is a very neat parallel here that you need to see. I have a geometric sequence. You do? Yeah. If I take this term and divide it by this, I'll get 0.75, and if I take this term here and divide it by this term, I'll get 0.75. Now here's the catch. Please listen to me. The only exception to this not being a geometric sequence is the 30 right here, the first 30 that we dropped. So could I not just pull that 30 out, and when I'm all done solving the problem, add that 30 back in the end? Sure, I could. I just want to know the total distance the ball traveled. So what I have so far is a sum for 4. Okay, now we're going to take the 30 and we're going to pull this out on here somewhere. There's my 30. Put a line across the bottom. There's my 30. Now I'm going to add these terms together. How many terms do I have? 1, 2, 3. But hold it. Remember, that was only when the ball hit the pavement 4 times. I would have to do it 2 more times. So I really have 2 more terms, terms 4 and terms 5. Let me say that again. I have these 3 terms I'm adding, but that was only for these drops right here. I need to add 2 more. So I'm really going to have 5 terms altogether. So what I'm doing is I have a geometric sequence. Even though I didn't find terms 4 and 5, I still know if I did find them, I would have a geometric sequence. So I'm going to find the sum of 5 terms, and then when I'm all done finding the sum of those 5 terms, I'll add 30 back onto it. So the sum of 5 terms for a geometric series is a subscript 1, which is my first term here, which is 45. There's my first term, 45, times 1 minus r to the n. Now r is 0.75 and n is 5 terms, all over 1 minus r, or 1 minus 0.75. Now, if I type this numerator into my calculator, 1 minus 0.75, all of that to the 5th power, equals, times 45 equals, I'm going to get a really long number up top here, something like 34.32128,906, and then 1 minus 0.75 is 0.25, so I'm going to divide that by 0.25, and I'm going to get 137.28. 137.28, but then I also have to add my 30. Come down here. So I know all of these falls here was 137.3, but then add your 30 right here from the initial drop, and the ball traveled a total distance of 167.3. That is a hard problem, and that was a very good problem. All right, number 24. Okay, number 24. After a problem like number 22, you definitely deserve an easier problem, and you will have that on number 24. And again, number 23 we can do Monday in class if y'all would like to. Okay, 24. Suppose you receive 10 cents on the first day of the year, 12 cents on the second day, 14 cents on the third day, etc. Question number 1, how much will you receive on the 365th day? Well, let's see. My first term is 10 cents. My second term would be 12 cents. My third term, or third day, would be 14 cents. I obviously have an arithmetic sequence, do I not? I'm adding 2 over and over and over, correct? And what I want to find is the 365th term, because it wants to know how much money will I get on that last day. Alright. Well, when dealing with an arithmetic sequence, there is a formula we've learned. when it's an arithmetic sequence that helps us find the nth term. And here is the formula. You know, well, I'll hold that thought for a second. Okay, there it is. So my nth term would be a subscript n equals, my first term would be 10 cents. As long as you remember this 10 is really 10 cents, n minus 1, and your common difference would be 2 cents. All right, there's your nth term. Now, you want to find out how many total cents over here that we'd have. Let's put 365 in for n right here. 365 minus 1 would be 364. So we have 364 times 2, which would be 300, let's see, what would that be? 8 to 728 plus 10 would be 738. Now, of course, 738, that means cents, just like 10 is really 10 cents. So what I would have over here is 738 cents, or $7.38. Okay? All right. Now, so I realized step one, I realized I had an arithmetic sequence because I was adding the same number over and over and over. Number two, I realized since I had an arithmetic sequence, I could use my nth term formula for an arithmetic sequence to find my nth term. I did that. Then I found the last term. Now look at the other question they ask you. The other question they ask you is, what is the sum of all of these gifts together? So now I'm going to add all of these 365 numbers together. Well, remember, I have an arithmetic series, so I have a formula that helps me find the sum of an arithmetic series, and the formula looks like this. I have to know the first term, and I have to know the last term. All right, so the sum of 365 terms is 365 over 2, 10 plus, now don't put 7.38 for your last term. If you're going to put 7.38, you better put 0.10 for 10 cents, okay? And my recommendation is just to leave everything cents. So just put 10 cents and 738 cents. Now, when I divide this right here, I'll get 182.5 times 748. All right, so let me grab my calculator real quick, and we'll take 748 times 182.5, and we're going to get this right here, 136,510. And remember, that's really dollars and cents, so move the decimal 2 places, and there you go. If you add up all of those gifts together, you would have $1,365.10. All right, not too bad of a problem. Number 25, and we're finally done. Suppose the government is making a $24 billion expenditure for travel to Mars. If 73 of this amount is spent, again, and so on and so on and so on, what is the total effect on the economy? All right. Now, here's basically what they're saying. You start off with this really big number here, 24 billion. And to find the next term, I'm just going to use cut and paste here so we're not writing that same number over and over. Then we take that number times 0.73, and then we would take this number here and multiply it again by 0.73. So this times 0.73, 0.73, and then it continues on. So hopefully you see what's going on. We're taking each number and we're multiplying it by 0.73 over and over and over. So we do have a geometric sequence or series, and we can see the common ratio is 0.73 because that's what we're multiplying over and over and over. Now when it says give the total effect on the economy, it wants us to add up all of these numbers. The only problem is, do you notice in this situation they don't tell us how many terms or how many years we have to figure this. Okay? So it's an infinite series. So in other words, we're going to have to use the formula right here, a subscript 1 over 1 minus r, as long as r is less than 1 and greater than -1, and we're fine. R is 0.73, so it definitely falls in there. So we're going to find the sum of an infinite geometric series. So for a subscript 1, I'm going to put 24 billion all over 1 minus r, 1 minus 0.73, and then using a calculator, if you type everything in correctly, 1 minus 0.73 of course is 0.27, and so take 24 billion divided by 0.27, and you will get out something like this right here. Now this is your sum or your limit, however you want to look at it. 88,888,889,889. Okay, so there we go. That's the total effect on the economy based on this money and how much of it is put back into the economy over and over and over. I know some of these word problems have been tough, and I know they're not the funnest thing you've ever done, but please really study these and work on these. I will give you some on the test, okay? So make sure you're ready for the test, and call or email if you have any questions.